Question number 2. So we've got 4 rectangles of equal width are drawn using the approximate area of a parabola. Okay, state the width of each rectangle as shown. So if it's a total, there's 4 of them, and we're looking at a half there, so we're looking at 0.25 wide. Okay, find the total area of the 4 rectangles shown. Find the total area of the 4 rectangles shown above. So the 4 rectangles shown above, looking at the total area. So that's a half, that's 3/4, and that's 1/4. So that there is 1/4 and 1/16. That there is 1/2, which is 2 on 4, so that's 4/16. And that is 3/4 and 9 on 16. And that's 1. So the total area of this one will be 1 times 1/4, plus this one will be 9 on 16 times 1/4, and this one will be 4 on 16 times 1/4, and this one is 1 on 16 times 1/4. And on my calculator, gives me 15 on 32, or 0.46875. So there was 1 mark, so 15 on 32 square units. Find the area between the graph and the line x equals 1. So I'm wanting to find the exact area, 2 marks. So the area is going to equal the integral from 0 to 1 of x squared dx. And on my calculator, that's going to give me 1/3 square units. Okay, the next question. Approximate this using 4 rectangles of equal width using the right end of each. So never anywhere did the word area come into it. Area is not what this question's asking. So I'm using the right end from -2. So the right end of -2 will be my first rectangle, 4, so 1, 2, 3, 4. Right end will be this. Right end will be this. That area is 6, that area is 2. Right end is this, that's -4, and right end is this, and that's -6. So I've got 8 minus -2 is the answer. Never anywhere in the question did it say the word area, so my right end is 6 plus 2 plus -4 plus -6. Parts of the graph are shown below. Find the area of the shaded region. So, and this is worth 1 mark. On the area of the shaded region, it's going to be the integral from 0 to 1. Top curve is root x minus bottom curve, which is x squared dx. And I'm going to do on my calculator. And I'm going to answer of 1/3 square units. And now we come up to part F. Okay, so what have we got here? I've now got this curve where I can be anywhere between there and there. Find the values of both sides between this and the line of that and that. Well, I know when A equals 1, which is exactly what I've got here, A equals 1, and I'm going from 0 to 1, the area was 1/3. So that's one of my answers. So A equals 1 is one answer. If A was less than 1, but bigger than 0, because A goes from 0 to 2, then it's looking like this. This is my parabola, this is my square root, and here is A, and this is the area that I'm looking for. So if I integrated from 0 to a of the square root of x minus ax squared dx and set that equal to 1/3 and solve for a. And I've got that there, so if I copy that, paste, execute, make the answer equal to 1/3 and solve for a. And I got 1 correct and 0.7702. And I'm giving these answers to 2 decimal places, aren't I? 2 decimal places. Therefore, a also equals 0.77. So if a goes between 0 and 1, I get an answer of 0.77. It also gives me an answer when a equals 1. What if a was bigger than 1? A bigger than 1, so a going from 1 through to 2, which means this is what my situation is going to be. A is bigger than 1, so my 1's over here somewhere. This is my square root. This is my y equals ax squared. And because a is bigger than 1, it's going to dilate it. So therefore, the intersection point is going to be somewhere to the left of 1. And I'm looking for 1/3 equals this area. And this area will be integral from 0 to the intersection point. Root x is on top. Then plus from the intersection point to a of this. So I need to find that intersection point. So I would like to find where root x equals ax squared, which means x equals a squared x to the 4, which means that a squared equals, x to the 3 equals 1 on a squared, x equals a to the minus 2/3. So I've got a to the minus 2/3 and a to the minus 2/3. And put that on the calculator, get my answer, set it equal to 1/3 and solve. I get a equals 1 again, and a equals 1.13. So I'm going to have 3 answers that are going to satisfy this situation. And my initial, which I already knew, a equals 1.